ये तो मैम बताना पड़ेगा ना।
Good morning to all of you. We will start the session by 11. Few more candidates are joining still. Our speaker, Dr. Harsh sir. Are you there, sir?
Very good morning, ma'am. Am I audible?
Yes, sir. You are clearly audible, sir.
Okay, great.
Sir, shall we start by 11, sir?
Sure, ma'am.
Okay. Thank you so much. Good morning and welcome you all of you to day 3 of our faculty development program. Let's stay engaged and make today as impactful as possible. I welcome Dr. Harsh Khattar sir, our speaker of the session. Currently, he is working as an assistant professor, associate professor in Department of Computer Science at KITE Group of Institution, Ghaziabad. He has 12 years of teaching and training experience. He is PhD in computer science on web services and recommended systems. He has published more than 40 research papers, including SCIE index papers. He has more than 60 Indian patents in his portfolio. He is an active member of IEEE, ACM, IFE, RP professional bodies. He has been appointed as teaching consultant with United Kingdom International Qualification of Limited. From August 2020 to July 2021, he was appointed there. Recently, in June 2024, Dr. Khattar applied for the professional proposal grant under Army Design Bureau Special Academic Scheme of rupees 1.03 crores. I welcome Dr. Khattar, sir. Please share your words of wisdom, sir.
Thank you. Thank you, ma'am. I hope I'm audible to all. So
Yes,
first
sir.
of all, I would like to thank Dr. Sachin Yadav, sir, Director, GEMS, Dr. Lata, ma'am, and Dr. Devendra Gautam, sir, my friend, and all the faculty members who joined the particular session. And it is my opportunity here to deliver the talk in front of you all. Let me share my screen. So today I'm going to deliver my talk on machine learning and AI ethics. As it is a 5 days FDP program, and today we are on day 3. I hope most of the experts already discussed about the basic terminologies of about the machine learning, deep learning, and what is AI. And so I don't know much about the other speakers and what they have delivered so far. So to the content relevant to my talk, I also touch few of the basic terminologies. And if at any point of time you feel yes, you have any doubt or query, then you can ask. And if you want to skip some of the content part, then you can also tell me. The whole session will be in different parts where first I will touch the basic terminologies specific to some examples, then why we are migrating towards the deep learning. So the 10 minutes, the starting 10 minutes, I will devote time on this. Then about the research problems. So major focus of the session will be on the research problems so that the faculty members and the research scholars get benefited with this session. And you can also opt from the shown research problems here in my session. I will also talk about some of the latest problems and their challenges where the industry and the society is suffering from. Then we will talk about the data set and what is the expectation of a particular university where you are pursuing your PhD, and if we are applying for the particular grant, then what they are expecting, the agencies are expecting about the data set, and how you can ensure yourself about the authenticity of the data. Further, we will talk about the AI ethics, and if there are few questions about the workflow, how the students are going to be, the scholars are going to start their work, or some uh, faculty members, those who recently joined the PhD and about to join the PhD, then we will also focus on this part if time permits. As we all know that broadly the machine learning is divided into the three parts, three categories of the learning: the supervised, unsupervised, and the reinforcement. And the very first part is whenever we talk about the machine learning methods and we are thinking of to work on the machine learning, then the very first part is yes, we have to opt for which type of problem statement we are taking off. And initially, when we talk about the data sets which are available at the different platforms and in the research papers, the beginners start with the supervised learning, where we are aware about, yes, this is our data and we are training a particular model, and based on the particular model we are now seeing the testing of the data is there, and we are basically classifying the things. Yes, this is belong to a particular class 1, class 2, and class 3. Or we can also group them on behalf of some labels which are already or predefined in our data sets. So most of the researchers start their journey with the supervised learning algorithms. Then further we have some unsupervised learning where we are keen to develop our own patterns. We want to analyze the data. We want to group them in a particular clusters, and we are saying, yes, these are some categories which we defined in our data set. Might be it is an existing data set, or we are gathering our data based on our own pace. And further, we have the third category where we want to evolve our data set. We want to evolve our machine learning model. And we are saying, yes, the learning is on a different pace where we are talking about some feedbacks, and based on our learning, our model is getting stronger and stronger. So this type of learning, we generally say it is a reinforcement learning methods. So I hope these three techniques are already discussed in most of the by most of the speakers in the sessions. So I am directly moving towards the problem statements and what are the categories in this. If we talk about the research papers and the research which we are seeing nowadays, then most of the research are on behalf of the classification where we have some supervised model. We are applying the supervised model and we are just predicting, yes, the data is or the input is relevant to the class 1 and class 2 or class A, B, C, or whatever the customized names we are saying. Say there is a some recognition model and the data set is related to the images, and now we have to just classify them that these are some objects or the humans which we are seeing. So these are some examples. Another one is based on the regression, where again we are talking about the supervised learning, the data set we have, and again we are predicting something, and based on this we are applying some methodologies. Then the next one is based on the unsupervised one, where we are saying, yes, the data we have, and now we are making our own patterns based on some features, and we are extracting those features and just saying the groups we are carrying of the similar objects, where we are saying these are the clustering methods. And the latest research is about the anomaly detection. This is the part which we are focusing on the industries and how the data we are getting, and based on applying some unsupervised learning models, we are saying, yes, this is something which we are talking about the descriptive part. Yes, the error is 2 point something, error is 3 point something. And based on the range of a particular output, we are just categorizing them. Yes, this is a most prominent thing, or this is the ignorable part. So based on this, we are just analyzing our data. Why I am discussing the basic things? Because when we are writing a paper and when we are seeing the research papers, we have seen on a same data set, multiple algorithms are applied. If you are using any suppose ABC data, and based on the ABC data, you are applying some machine learning models, and you are seeing, yes, the trend is about the SVM. So you are applying SVM, but somebody says, okay, apply the regression method on this. Then you start applying regression. You are seeing the codes on GitHub and other repositories where you are seeing the regression is there, then the linear regression is there. Somebody is saying, okay, apply the random forest. Then we are just obeying the guidelines, or some of the reviewers are saying, yes, you can apply these algorithms, and we started just comparison of these. But this is not a good habit when we are talking about the demonstration of a particular data set by the help of some models. Because if I take this example, here we have three different categories of data. I'm not focusing on the name. The objective is just to show what is the problem in this. So in the first line where you are seeing the algorithms are almost same. I have taken the nearest neighbor, then the SVM, then the decision tree. That is fine. But when we talk about the accuracy of all the models on different data, then the accuracy varies. Like in the very first data, this part, you are seeing the nearest neighbor is giving the maximum accuracy of 97%. But when we talk about the next type of data, then the accuracy is 80%. So it is not like this that you have used a particular model and you are comparing the particular model with the other competitors and you are saying, yes, the SVM always perform better. No, it is not like this. It depends on the type of data which you are taking. Sometimes the data has various parameters and sometimes we have the very few features to extract. So it depends on the data set which you are taking and accordingly you have to apply the machine learning model. So this is one example and we just focus on that what type of data we have and then try to use the algorithms. Generally, we say, yes, we are working on the LSTM and now this is a data set. Now we are trying to apply the particular data set on means LSTM on a specific data set, which is not a good practice. So first identify what is the exact input, what you are expecting is the output, and based on this, we need to opt for a particular model. And accordingly, we are going to change the model, might be it is a hybrid approach or you are creating your own model based on the existing ones, and then you can get the relevant outcome. This is one example. In the part A, you are just seeing a one image. So what we are trying to fetch from this particular image, I hope the audience is also there and it will be an interactive session. If you have any questions, any views, any thoughts, then you can also share. So yes, the comment box is also on. Separately, I am also viewing the comment box. So if the audience is there and you are seeing that which type of algorithm which we are using here, our very first thing is what we are trying to fetch from this. Yes, a person is there, some sheeps are there,
Object.
and one dog. Yes. So we are talking about the object detection. So here, the main question is which type of model we can apply here. Now, some of the means faculty members are thinking of, yes, this is not a simple machine learning model, or this cannot be possible with the simple algorithms which I have shown in the previous slide, like SVM, and we are talking about the nearest neighbor. So here we need to apply some deep learning model. So very first question is why deep learning model, or what is the difference between the machine learning and deep learning? If I am taking this example where we are detecting some images and then we are applying the segmentation. So here, because I am using the three terminologies like classification, detection, and segmentation, that's why we can say the deep learning is applied. So here, I just want to clarify this thing that deep learning is something which is the more depth part of machine learning, where we have the larger features, larger data set, means the number of tuples are more, the number of features are more. We are applying the various methodologies, various approaches, and the network which we are using, means the neural network which we are using is more dense. So that's why we are saying yes, deep learning is something which we are using. If anybody wants to talk about, yes, what is the main difference between the machine learning and deep learning, then I will be happy to know this. Then we will link some more slides on this. Okay, so the main part is what is the main difference between the machine learning and the deep learning? Yes, we all agree on this that machine learning or deep learning all are the part of AI, and AI is a superset of all. And then we can say, yes, the selective part of the machine learning is something which we are saying deep learning. So can we say if we are using the deep learning, then machine learning and AI is also there? Yes, the answer is yes, it is true. But can we say always we will get the better results when we are using the deep learning?
No,
As
sir.
yeah, yes, it is not true that if we are using the deep learning, it doesn't mean that yes, always we are getting the better results than the machine learning or the basic models. Now, what is the reason behind this? The reason is if we are using selected entities, we have some limited features, we have a data set with the limited features, then the size of the data set is also small. So in this case, now small, what is the meaning of small here? It is again a vague term which I am using. Means if we are saying two or three entries are there, it is also small. But when we are talking about a data set, then 100, 200, 500 entries are there, then again we are considering this as a small. So what is the meaning of large data set? The large data set means when we have the lakhs of the entries. Means suppose we are talking about the weather forecast data set, and we have a data of every 10 minutes, and I am talking about the data of say 5 years. Now we are talking about it is a big data because in 1 hour we are getting the four entries, in a full day we have the 100 entries, and now we have a 5 years data, 15 years data. Now we are saying yes. So in this case, when we talk about the methodology which we are using in the machine learning or the basic models, no, here we need some more depth, and we have to deep dive in the neural network layers and the processing of the each neuron, each layer. And further we are saying yes, it is a deep learning model based on the methodology. So what is the change in this? Journal in general methods, we can say we have the input, we are applying some neural network layers, we are mapping the features with the particular model, we are getting the output. But when we have the large number of features and we are fetching, yes, these are the relevant ones, and we are also applying some rules to set, yes, this feature is the most prominent one. And based on this, we are analyzing or ranging our old features. Like we have 30 features to identify, or we are fetching the 30 features from the input. And based on this, my objective is to get some relevant output in the one or two forms. Means I'm talking about say multimodal network. So in this case, the features are mapped with the layers, and the neurons are act accordingly based on our features and the working. And then we are saying, yes, we have a dense network which is providing a model, which is a deep learning model, and then we are getting the values. So yes, the answer is true, is deep learning is a subset of machine learning, but the answer is false if we are talking about the deep learning always perform better in terms of machine learning or in comparison of machine learning. No, it depends on the data set. It depends on what we are expecting as the outcome. So if I talk about the deep learning methods, yes, one more point which I left in the previous slide is generally when we are writing a paper and I'm suppose there is a paper I'm writing like a recommendation system using the machine learning algorithms, and I am seeing the rejections because now the trend is of deep learning, and I am now changing my title to the recommendation system using the deep learning models. So the chances of acceptance is more. No, it is not like this. But some of the faculty members, some of the research scholars are thinking, yes, if you are using some deep learning terminology in your paper or title, then it will be accept. And if you are using the machine learning, now the machine learning is out of the trend. No, it is not true. So when you are focusing on deep learning, it means your paper or your research work shows, yes, your data set is much more, and the features you are considering, the outcome is really want to use a deep learning model. Only then you can use the deep learning terminology. Otherwise, you can use the machine learning terminology. Yes. So what is deep learning process if we want to do some research on this? So first of all, the very basic thing is understanding the problem statement and what we are expecting. If we talk about the basic algorithm, not a machine learning algorithm or deep learning algorithm, the very basic part is to understand what we are expecting. What is my input and what is a particular output? Based on this, I need to make a process. Based on this, I am deriving my own algorithm. And then I can understand, yes, these are some intermediary steps which I need to follow. And to achieve these steps, to achieve these intermediary results, I need to identify, yes, the machine learning is sufficient, or a particular, say, only the fuzzy rules are sufficient. Might be the machine learning model is again a bigger thing for my task. So I can just apply the fuzzy rules on this and I can get the result. If it is not so, then I need to focus on the machine learning models. And yes, if I have a dense input size and if I have a outcome, an outcome where I am expecting something more or in depth, then I am trying to use the deep learning model. So very first thing is to understand what is my input and what type of output I am expecting. Based on this, I am applying some sort of algorithms on this. Based on the algorithms, now I am identifying, yes, what is the need. And then I am saying, yes, deep learning is required in this. And finally, I am getting the output. So output is in terms of some graphical representations based on some parameters which you are fetching, some performance indices or some matrices. So these are some outcome parts. This is one example where we are showing, yes, the three hidden layers are there. So again, there is one question in the mind of the researchers that how many layers can be there in the deep learning model or the dense network or in a normal machine learning model. So again, it depends that what type of working you want to do with your particular model. What is the need? What is the expectation of your model or your algorithm from particular system? If you are getting the results based on the basic computation in the two layers, then why you are using the five layers or six layers? If generally we are using the six or more layers, then our network become dense because each and every neuron in a particular layer is performing something. You are applying some computation and a computation will take time. Again, it depends. Suppose your input is the image, then might be your single model will take hours to compute and get you are getting the results after 6 hours or 7 hours. That's why we are saying, yes, we need a higher performance units, like we need the GPU or we need Param Shavak or DGX type, means computational resources we need. So here, very first thing is the proper understanding of a particular data set which we are using. Based on the data, we need to fetch a particular thing. Now, if I compare this particular model, then we can say, yes, this is we have a dense neural network where each and every neuron has a complex computing function. And based on this, we are going to fetch, yes, there are so many activities in a particular data set. There is a swimming, there are some images from the persons who are running in the particular field. We have some images of the fruits. We have some images of the activities to be performed by a particular person. We have some of the images of the uh, means geographical images. So when we have these type of images, the scattered data, then the computational which we need is something more than we can't have in the previous or the traditional machine learning models. So here we need to focus on these things. And when the computation is more, we need the more computational power, then there is a need of some heavy processing units like GPUs. Then we are focusing on this. So when you see that you are applying or working on the deep learning models, then yes, the images are there. Then there is of course a need of the large computational unit like GPUs and the DGX servers or Param Shavak sort of things. Let me just highlight what is the journey of the AI and then the machine learning and how the deep learning is evolving and is in use by the various companies. So this is the one just a layout to show you, yes, this is the history of AI, ML, I just added this. I hope this is already covered in the previous sessions. So I am not focusing on the above ones, but I am focusing on the last ones where we have the GAN, the generative adversarial network, which we are generally focusing on to creating the new images, then analyzing of the images, and then we have the various other models like the DeepMind, the Google AI, we have the BERT, and we have some the uh, means we can say the generative models we have, and in all these type of models and the applications we are using the deep learning. So we can say the last line, 2012 onwards, we are now stepping in the deep learning era, and we are using the models where we are focusing on the dense part, the computation is more. Yes, there is one more question in the mind of some of the researchers. Like, we are in the era of deep learning. So this deep learning is now evolving. So the machine learning or AI is obsolete or not? No, they have the separate characteristics. Previously, I gave an example of the ML and the DL, that machine learning has the separate characteristics and the deep learning has their own participation. But when we talk about the research, so AI is something where many more algorithms are there. If I am just talking about the fuzzy logics, I am just applying the rule-based system. So in the rule-based system, I am not applying the deep learning. I am not applying the machine learning algorithms, and I don't want to make the learning of my system. I just applying, yes, if the temperature is this much, if the humidity is this much, and these are the constraints which I am applying, and I am getting the results. So again, this is a part which is under the AI. And still there are so many projects, there are so many companies who are working on the AI, and they are not focusing on the machine learning and deep learning. Similarly, when we talk about the problem statements, so in the research itself, suppose many of the faculty members present here who are doing the PhD, so everywhere you are not applying the deep learning model. At some instant, you are applying the deep learning, and yes, once the part of deep learning is done, you are just getting your outcome. And further, you are applying some other concepts, might be for the visualization purpose, might be you are applying for the categorization or the classification purpose of the result. So here the multiple algorithms can be applied. And that's why there is a term which is also evolving nowadays, that is known as the hybrid computing. So hybrid computing is something where you are applying a particular part, the deep learning on a specific part. Then your second objective is met with the basic machine learning algorithm. And the third objective which you are seeking of is completed with the basic fuzzy inference engine. And then you are applying some visualizing models like the data science models and data analysis models. And then you are saying, yes, it is a hybrid approach in my PhD work. And this is the hybrid computing part. So it is not like that the AI is the initial, the basic functions are now obsolete and ML is also obsolete, and now we are only focusing on the deep learning. No, again, it is based on the input, the data we have. Now, I'm just focusing on some of the research problems where still we are focusing on the accuracy. We know that some of the papers we are seeing where the object detection is there in the previous image as well, where the person is there and some goats, sheeps are there and one dog is there, and we are applying the various models on them. And yes, we are saying the accuracy is 97%, 98%. Okay, again, I want to interact with you. We have seen various papers where we are seeking, yes, this paper is best because this paper is showing the accuracy of the object detection model is 98%. And we generally opt for a particular paper as a base paper, and we start our research on behalf of this. So do you think if there is a existing paper where the accuracy is 98% and there is a scope of improvement, and you are sure that you can spend your 3 years, 4 years, or 5 years of PhD or your research to achieve the accuracy of 99%? What do you think? Means Is it better to opt for the paper with the 98% accuracy, or you are searching for some other paper with the accuracy of 86 or 87%, or the 70%? What do you think? What can be the base paper? Yes, you can also type in the chat box. What do you think? Option A, the paper with 98% accuracy. Option B, the paper with 88% accuracy, or the paper with 78% accuracy. And if all three papers are published in 2024 and in the impact factor more than 8, okay, like expert systems. So what do you think? What will be your base paper?
Sir, it's depend on, I think it's depend on scenario.
Yeah,
If we are taking like accuracy with 78%, we can improve with some new technologies, some new advanced features that is not done. Yeah, if that is done, we can combine it and implement it. But with accuracy 98% is it's bit difficult. Uh, I think they are already done all the stuffs. Like actually, I read one paper with the same scenario.
okay.
Yes, sir. But they already hybrid multiple methods and techniques, and they use optimization techniques. They use attention techniques there, and so then I switch according to me, I switch
Yeah,
some other field like with accuracy 78%. It's depend.
yeah. Yes, very true. Means the concept, as ma'am said, it is correct. But there are so many other parameters as well. Because when we are reading a paper, we this is our mindset. If we are using a research paper of the high class journal and the impact factor is more than 8, and it is also a recent publication of 2024, and the accuracy is 98%, then there is no scope of the improvement. No, this is our myth. First, we need to understand what type of data set they are using, and how the particular paper is dealing with the outliers. So this is very important part to understand. Sometimes we have seen, yes, the data set which they are taking in their paper is a customized data set. They have modified the data set and they are only focusing on the specific features. So, yes, you can use the same paper of 98% accuracy, and your objective can be a different part. Like you can now focus on the multiple features, means you are focusing on the multiple outcomes. Suppose they are only focusing on the accuracy part and accuracy of in between the two classes. Now, suppose in the image you are seeing on the screen, there are a single expression surprise of both the means the father and the daughter. But if you will see here that we have the 8 expressions, the natural happiness, sadness, and this. But in the particular paper, they are only focusing on the it is surprised or not. So obviously, when we are focusing on this type of thing and the class is only two, that surprise or not, then the accuracy will be more. But when I am deriving, yes, the neutral is there, the happiness, surprise, and if I talk about the just surprise, shocked, and happiness, almost the expressions are the gestures are same, but the accuracy of the same model on the same data set might be it is the 78% because we have elaborated the classes. So as ma'am said, yes, we have can apply some other attention methods. We can apply some optimization methods
Sir,
as well. Yes, yes,
yes, so exactly the same way as you are saying. The third someone has adopted this paper as a base paper, and
yeah,
in this paper they are just proving the accuracy of depression, and the someone third is uh, with the depression they combine some other emotions like
yes.
yeah, with the depression, the suicide. Yes, they combine this type of data set and then find the accuracy again. So main objective is your objective is some bit different from.
Yeah, and the universities and the panels, the RDC panels, they are accepting this. Yes, you are taking the base paper of 98% accuracy, but
Mm.
now you are just elaborating the outcomes as well. Further, you are taking the outcome of a particular paper and now you are elaborating, you are further classifying those. and now you are making it in the 3 categories, 4 categories, even 10 categories, 16 categories. Yes, you can say the level 1, level 2, level 3. So obviously the accuracy will be less, but you are giving something as
So
a research
correlate,
part.
they correlate how depression is pressing people to get suicide. Like
Ye-
how, yes,
yeah.
like this.
Yes, this is one example where you can say, yes, what is the stress level, then how it is converting to the depression. Then for judging the depression, there is a separate accuracy. Then further, you can just predict or you can just analyze. If I suppose there is a data set which is available where you can see, yes, how many suicides are due to the depression. I think
Yes,
ma'am
sir.
is asking
Yes,
about
sir.
this.
Yes, sir.
So,
Yes.
and you will see there is a great number at the percentage of the depressed people who are
Yes.
committing the suicide. And again, there are few research papers on the same that how many candidates are like this who just wait for a particular moment after a depression and they can just skip a particular moment of suicide claiming. So these are few things, few parameters, few features which we can use and enhance our result. So this is the one parameter that we can take a base paper of 98% accuracy, and further we are evolving through the models. We are just extracting the more things as the outcome, and we are getting the result say 90%, and the base paper is giving the 98%, but still the PhD is awarded, and again your paper is published in the same journal of more than 8 impact factor because the nature of the outcome is different. So this is one example where we need the deep learning models. So similarly, there are so many mobile applications are available from the last 5 or 6 years in our mobile phones where you can just click your image and based on the selfie camera, they are just identifying, yes, they are giving what is your age and what is your gender based on your facial expressions. So again, we have some deep learning models applied here. So if somebody is seeking to work on the particular research area, then you can also pick these like the object detection, then the emotion analysis based on the facial expression, then the activity recognition, because there are so many cameras. The CCTV cameras are nowadays we have, which are the intelligent ones, and based on the movement, they are giving some sort of alarms when they are recognizing the activity is some abnormal activities. Suppose on the road, we are seeing everybody is moving, the cars are moving, but whenever there is an accident scenario where the objects are hitting each other, then we can just say prompt can be there from the CCTV based on the activity recognition, and they are seeing yes, there is something which is abnormal, and they can give some alarming state to the control room or the traffic control room or some sort of the means authorities or the national highway authorities. So these can be some areas where you can work on. One of the proposal from the NHAI is there where they are demanding for the software solution which we can provide to them based on this activity recognition, and wherever the accident is there and based on the footage or the camera clip, they will give the assistance. So currently, we need to call the particular toll-free number on the NHAI, and then they are giving the response, and the rescue team will come in 10 minutes or 15 minutes. But here, the manual intervene is required. But now they are expecting, means the proposal is on, and the last date is 31st August, and they are demanding for a software solution. So these are some things, means the basic problem is there, we are applying a basic solution, then we are working on, yes, this can be the depth of the particular solution, we are applying the machine learning models, the deep learning models, and then we can also writing the papers. But when we have some paper, we have such approach, we are working on this area, then we can also see the proposals of the government. So if you are working for a such initiative or the proposal of the government, then again the chances of the research paper publication is more, because now your research is funded by some organization, the government organization. So some of the researchers who are working on this area can also focus on this part. Yes, the another important area is the medical care, the healthcare, where the deep learning models are means applied. This is about the image colorization. I am just giving the overview of few of the applications where the research scholars can start their work, or the faculty members can just focus on, and they can also apply for the research proposals on the grants. So image colorization is there. We have seen now in the film industry as well, they are focusing on the old black and white movies, and now they are converting to the. Can anybody give me one example that how the any one example of the movie which is converted from the black and white to the color and re-release? So there they are using the image colorization where they are working on frame by frame and giving the results. So these are some examples. This is another example where you are just giving the two images, and based on the two images, you can just say, yes, we need this particular font, this particular format, and this particular color, and we want to change the complete thing. So these are the another area where the deep learning models are applied, and they are giving the perfect picture. So here you can see a yellow flower is there and the red rose, and the color is picked from the one image, and the pattern is picked from the another image, and you are getting the new image as a result. So here, one deep learning model, the photo style transfer is the learning method which is used here. So which is again a subset of the deep learning model. Again, we have another picture, then we have the reference photo, and we are getting the result. So this is one area where the image processing scholars can work. Object removal. Similarly, we have the object append, and this is a object removal. You can just focus on now. Most of the cameras, also the mobile phone cameras, are now smart, and they are using the graphical models. They are also giving such sort of features that you can just erase the things. You can just means in Android there is an option of the magic eraser sort of, where you can just highlight the things and the object is removed. So still means why I am showing this, because the accuracy is not 100%. So you can also focus on this. If you want to enhance the accuracy, you can work on this. Let me give you one example. This is the another one, which is the image completion. Means we have a distorted image, and we need to focus on this distorted image, and we need to complete it. So in completion, generally we use the filters, the averaging filters we have, and so many other image processing filters we have. But only with the filters the things can be easy. Sometimes we are seeing, yes, we have applied the filters, and now we are checking the accuracy of the particular filter, and the accuracy is 80%. Yes, we are seeing the images, so based on our naked eye vision, we are unable to judge, yes, what is the accuracy we are seeing. Yes, it is 100% accurate. But the answer is no. When you are analyzing with the deep vision, the computer vision methodology, then you will analyze, yes, the accuracy is less. So how we can improve this type of things? So again, this is one area, the research problem we have. This is nowadays it is in the trend that we have some visuals, and based on the visuals we are seeing the edited audios are there, and how we can just focusing on, yes, the synchronization between the images and the lips and the audio. So this is the one uh, area which we have. Another one is like this, you can just understand this part is something which we generally need. And now the trend is something, and we are moving towards the deep fake, and we are seeing the videos are there, and now the celebrities are claiming, yes, the image is correct, but the audio which is imbibed in this is not his or her. So this is one area as well, and the researchers can also focus on how to judge this, because it is quite tough to understand, because the pitch or the frequency of the words which model is using, this is same as the natural language, natural audio of a particular person. So here the natural language processing is used, various other models are used to synchronize between the video frames and the audio and the lip movement. So this is quite tough to understand. Similarly, you can work on the positive side as well to retrieve the things in the forensic, in the cameras where the audio is not there, only the visuals are there. Then you can also work on to recognizing the lip reading and what is the speech behind the particular scenes. So you can also work on this area. Then the another one is about the image processing, and in the image processing, even to just make the images in the higher resolution. And over the years, what can be the changes in the face? There are so many mobile applications which are available where you can just upload your image, and you can just the system will predict your image of the after 40 years, after 50 years, and at the age of 80, how you will be, what are your facial expressions and how old you are, based on the wrinkles and all, based on your facial expressions of now a time, you can just predicting after the 30 years or 40 years what is your age. So in such sort of images you can also work. And there are other multimodal ones where you can also talk about the basic features, but also you can talk about the expressions. There are various things like one, you are recognizing only the image. Another one, you are recognizing the image of a particular person plus the emotion. Then the third parameter is you can analyzing the name, means recognizing the person. You are recognizing the facial expression. You are recognizing the particular age. So when we have the three parameters or four parameters to predict, then we can say yes, we have a multi-domain image. And then we are working on various projects. We can work on the various problem statements like image to image translation. Like you are uploading one image of a particular person. Suppose I am uploading my image, and now I am just tabbing here on my phone like anger. So the system will predict me, the model will predict me, yes, this is the face when I am angry. Okay, I am entering like the surprise. So now the image is giving by the system where my face is there with the surprised emotion. So you can also work on this area, and further you can work on the accuracy of a particular model. So these are some research problems. These are some problems which are unsupervised learning models, means these are the AI generated images. You are just giving one image and you are just evolving the image, and you are seeing the model is evolving and giving the answer like the AI generated image. So these are the latest research problems. Latest means from last 5 years, 6 years, the work is in this area. So if still you are focusing on some traditional algorithms, traditional problem statements for your PhD, so it is suggested that you can seek some new topic and the images and focusing on this type of thing for your research perspective. So now I am talking about the next phase. So next phase is about the data sets and how we can choose this. So I will start the data set part from this particular image, that what this image is saying. First, we have a basic image, then we have some image with the obstacles. So we can add the things, we can remove the obstacles. So these can be easily done when we have a good data set. But in this, we can say still there are some issues. What are the issues in this? When you focus on a particular image, suppose you are seeing the image in the middle, and now you can see when you will remove a particular image, suppose these two persons are removed, still your model is giving the image like this. This one, the third one you are seeing. Here you are seeing that no image is there. But you will when you will zoom on this, then you will see, yes, there is some part of a particular candidate which is hidden in a particular plants or the trees. So these type of things are still left. So the researchers can also work on this, where some features can be there, or as the ma'am said, yes, the optimizing algorithms can be applied on this, where we can do the some self attention methods are there. There are some other methods to improve the results. So first we are applying the deep learning models, and further we are enhancing our outcome. So I'm just skipping and moving towards the data analysis. Yes, so I think, yeah, there are many more examples. So I think if I will cover all these examples, might be the session will take the more time. So I'm just skipping this. Yes. Yes, this is something where I can give some time because we are focusing on the Amazon Echo and the Alexa we have and other systems we have. So when we talk about the machine learning and the security, so this is one part. Although the images for some other purpose, but now I am focusing on because the FDP is also about the security. So how many of you agree on this that Amazon Alexa and this device only works when we are talking the term or a specific keyword Alexa, and otherwise they are inactive? So is this a statement true that the device only works when we are talking about a particular keyword that is Alexa, otherwise the device will be inactive?
The device will not be inactive because to understand whether that word is spoken, the device has to be active.
Yeah.
It
So
has to
that is
sense.
true. Yeah. Means the device is active all the time. The device is listening us all the time, but it is responding us when we are talking about a specific keyword Alexa. So this is something why I am taking this example, because means we have seen the system is giving you the recommendations based on your search. Whatever we are talking now in our mobile phones, there is one more example in our mobile phones. I am using a Google Pixel, and in iPhone as well, whenever a song is playing in the background, suppose in your television, a song is in the background, and your system is giving you the suggestion or giving, yes, this song is playing in your surrounding. So how? Because my mobile phone, even it is in the locked manner, my mobile phone, the devices, means the Amazon Alexa, the Siri, they are judging. They are just analyzing what are the surroundings, what are the senses are running. They are just sensing what is the sound. Based on this, they are acting. Means you will see so many case studies are there that the husband wife are fighting on a particular thing, and the Alexa ordered a particular thing from the Amazon. This is in the news of last month. Means these type of scenarios are there where the devices are now sensing. So why I am discussing this example, that yes, there is also need of the security, and we need to focus on that we are using the technology, but out at what instinct it is required, and at what instinct it is required from our side to stop this. So this is one example. I will also link the same example after 15-20 minutes when I will talk about the AI ethics. So this is one thing. So similarly, there is another scope of research in the text generation when we are talking about the captions are there, when we are on the call, or suppose what I am saying, and automatically it is converted to the text. So this is about the application, the sum of the research problems, and what I talk about the machine learning and the deep learning area, that these are the top industrial AI use. And in most of the things we are using for the predictive maintenance in the industry. So this is completely about the industry oriented slide. Is this, and based on the survey of 2019, that yes, when we talk about the particular industry, then these are the ratio of AI applications and the AI models which we are using on the different domains. So like we are talking about the bug detection, we are talking about the supply chain optimization and the smart assistants, like we have the chatbots by each of the industry in the website or the mobile applications to assist the customers. Now, this is the second part about the data and the models. So this is specifically to the data set. So when we talk about the data set, I also give one example that we have a large data set. So what is the meaning of the large data set, and what is the meaning of the small data set, and how the machine learning and the deep learning models are in relation to this. Okay, there is one more question to all of you. What do you think when we are talking about a particular model? then what is the acceptable ratio between the training and testing data?
80-20,
80-20,
70-30.
70-30. Yeah. Any other? Okay, so as we get these responses of 80-20 and 70-30, so it means yes, 70% and 80% we are taking the data entries for the training a particular model, and for the testing purpose we are taking the 20 or 30% entries. Now the question is, if I am talking about the same data set, the same model is there, and I am taking 20% as the testing part and 80% as the training part, and the another model, the same model is taking but is a fresh model, and I am using the same data set and talking about the 70% training and 30% the testing part. So which one, scenario A or scenario B? What do you think? The accuracy of scenario A will be more, or the accuracy of scenario B will be more?
Sir, 70-20, I think giving much better result because sometimes if we are taking 80-20, 70-30 in case if some data are not in our like training phase, 10% data, some data set are small as compared to others, some labels data. If we talk about some label data, if some label data classes are very less, and that case, if we say ki data set is not balanced, that
Hmm.
and that case, if we are taking 70-30, maybe some classes are going to some training testing section. So that case, result may be some bias result, not much accurate.
Okay, so why not we are taking the 90-10 ratio? If the 90% will be the
I
training
think
and
model get
10% will be the
overfit.
testing, model will overfit. But you have the all the entries, means you have a data, and the data set already has all the entries about the outcomes, and it is mentioned completely, yes, the answer will be this. And I suppose the answer of the 10%, whatever you are testing, you will get the 100% accuracy.
Yeah,
And
but
you will, yeah.
but sir, in
Mm.
case of small testing data, you are not testing enough then. There is an optimum this thing, because if you test on a very small data, then the chances are that it might go bad on larger set.
Yes. So means few things which come out from this small interaction is, number one, what is the size of the data set? Means how many entries are there? So it not only depends on the ratio that we are taking the 80-20, 70-30 or 90-10. And the another thing which is still missing, I am taking one more example. I have seen one research paper which is published again in the SCI journal, and they have taken the 60-40 ratio. So I have gone through, means from this paper only I came to know, yes, why the people are also focusing on the lower one, because this is our mindset. If somebody is taking the 60-40, then obviously the accuracy will be less. But are we able to understand that really the research is coming from this? If we are taking the data ratio, the testing and training ratio 50-50, what will happen? The accuracy will be increase or decrease?
But as per, it's depend on data set scenario, like either data is
Yeah, we
bad.
have a large data set, and on the same model we are applying, and now we are using the 50-50, 50% training and 50% testing. What is the general trend? The accuracy will improve,
General
or
trend is if
Ideally,
yes, yes,
ideally, sir, it will decrease
decrease. Yes,
because the ideal situation is to take like large data set.
yeah, yeah. One person more was giving the answer. Yes, sir.
yeah, sir, I think it in terms of an analogy. Like, for instance, I have to give an exam. Now, how much do I prepare and how many tests I take? It's
Yeah.
like that. So if I prepare a lot and just give one exam or one test, maybe I'm not good enough. And if I take a lot of exams and I don't prepare well, then again, it's like that. If you're taking a 50-50 data set, and training and testing. In that case, your training is not enough and testing is on the higher side. That also might decrease the accuracy. That's my take on this. I may be wrong.
Yeah, no, you are not wrong. And yes, partially means your point is valid, and I accept this. Because when we focus on that, which type of problem statement we have and what we are expecting basically, if our corpus is only a limited data set, what we have, suppose we have the 10,000 records, and out of those 10,000 records I am using for the testing, training and testing purpose only, that is fine, that I can take it the 70/30 or 80/20, and based on this we are using the multiple hooks and crooks we are applying, and we are saying yes, the accuracy is more. But when, as sir said, one example about the examination and doing the practice and give the exam, in a same manner, if suppose I want to predict something, so always my prediction is for some real data. I am asking about, yes, what is the exact weather of 5 days, means after 5 days what will be the weather. So in this case, I this is something which is unsupervised. And when we are talking about the unsupervised data, if I am training my model with the 80/20, so 80% it is getting the data, and then we are just predicting yes, 20% result is correct. But when we are giving the result, giving the real data to get the result, we are not getting the exact results. That's what we are seeing here in the Indian system, the weather forecasting system. You can see in your mobile phone, the weather applications are giving the result, and they are saying, yes, today it's a rainy day, and yes, it is a sunny day. Means I am not seeing a single drop of water nearby me, and yes, the system is predicting, yes, it is a heavy rain or the thunderstorm is there. So this is something when we are talking about the underfitting and the overfitting. So this is something which needs the more consideration, that what type of data you are basically evaluating. You have a data which you are taking only for the testing and training purpose, and yes, that's all. But now when we are talking about you have some real data and you need to analyze them, then in such scenarios your training ratio and the testing ratio is something equivalent, like the 50/50, like the 60/40 is there. So in these terms the 80/20 won't work. So it depends. So there are various features we need to focus on while using a particular data set. It is not like that, yes, in a paper we are seeing the accuracy is 98% and the 80/20, and yes, there is no scope of improvement. Might be there is some sort of issues when you are giving some uh, other entries, some outliers are there. So based on the outliers, again, the ratio will change. So this is one perspective. So just I take this example to inform all the audience that yes, it is not like that 80/20 if you are taking, then it will give the better results. Might be when the real data is there, it will not perform well. And the system which is working on the 60/40 will perform well on this. Yes. Another important thing about the data set, generally we are taking the data from the sources like Kaggle, UCI repository, and some of the researchers are now also using the data which is available on the GitHub, because they are saying the other models are there, and you are using the codes from those models, and you are changing the codes, or you are seeing, yes, this is a traditional model and the code is available. Now we can just manipulate something in this based on our data set, based on our need, based on our outcome, and we are making our own models. Generally, we are performing this task. So the next important question is, what is the authenticity of a particular data? Means, can we say the data which is available on the Kaggle, we can use and we can claim, yes, this is my PhD work and I am using this particular data set, and that's fine. But when we talk about the eminent institutes, they are saying, no, what is the authenticity of the data? So how we can say, yes, my data is authentic? Means the data set which I am using is authentic data. What do you think? Any comments from the audience? Any parameter?
I would definitely look at the source of the data. For instance, on your right-hand side in the table, the geospatial
Uh,
database, you have the NASA
yeah.
SEDAC, NASA Earth Observatory. So probably I would rather go with such kind of data where the source is authentic, where it's some government organization or some organization which has good authenticity in the market is handing out the data. But the flip side is that such data is not very useful in all the cases, and it's
Yes.
difficult to find.
Yes. So, yes, well answered. Yes, very first thing is we need to identify the source. If I am saying, means the data is given by you, suppose you are working on some medical data and they are giving you the data of your data of the aims only. So, yes, you can say the data is provided by the government agency and the aims is providing this data about the means healthcare. Obviously, it is a authentic data. So very good thing is that we can identify the source and we can also focus on not only the SCI papers, but the papers, SCI papers with the data set from the particular agencies. There are various funded projects and they are giving their own data. Suppose I am saying, yes, I'm working on this particular model and I am using the say VGG net on this particular and my accuracy is 98%. And when I am applying for the grant, then the agriculture department is saying you have to apply this on the crops. And these are the real images, and you have to work on this. So they are not asking about the my ResNet or my models. They are saying, okay, if the accuracy of your model is well on our real data set, then we will claim this. Then I am using those data sets and the accuracy is different, and now I am publishing the paper. So if you are using those data sets, these type of papers where the source is defined and they are saying yes, it is a government funded project and the data set is from the government side. So this is one thing which you can focus on because this type of data is much authenticate than the other data sets which are published by some other person. Suppose I am using a data set of the plant data set. I am saying that I have clicked the images of the various plants and I have a data set of 10,000 images. Now, based on my model, I have trained it. I am using the particular images. Suppose out of those, 1,000 images are there which are the outliers and due to which my model is not performing and the accuracy is less. I am just removing those images because it is my customized data set. So can we say the paper is published in the SCI and yes, I am using my customized data set and the accuracy is this much. So you are also using the particular data set. No, I don't think that this is a good choice. But yes, there due to the unavailability of the various domains, various data sets in a specific domain. So in this case, we are using this because we have to show the comparison as well. Suppose you have a data set, but none of the paper is published on this, then how you will compare it? Because you need to show in your PhD or in the other SCA paper that this is a comparison of your model with the other models in the same data set. So yes, still there is a fight among the data set and the models, but still we can focus on the authenticity of a particular data set. So as mentioned in the particular table, there are so many links where you can see the data set from the particular organizations which are published by the organizations. So this can be the first choice of the researchers to focus on the data set from the particular organizations and don't trust the data set which is only available on the Kaggle or the GitHub repository. Yes, you can use this for the initial purpose, for the demonstration purpose, but when you are publishing your research, just focus on the good quality data set. This is what I am explaining. Like I have a particular data set of the images and I am doing some sort of hooks and crooks to improve my results. But this type of thing is not acceptable. So I am just ignoring this and I am giving the good thing to you. Like this is one website in the India as most of the audience and the faculty members as the audience are from the Indian institutes. So you can just go this website instead of the Kaggle, you can just move to the indiaai.gov.in. This is the government officials website where all the government data sets are available. And these are free of cost. They are providing you the data set and you can just work on this. So I suppose more than 100 data sets are published on the different sectors. Means you can, from the agriculture department, the plant disease data set is there. From the AIMS, the data set is there. About the cancer prediction is there. The blood report data set is there. Sensex data set is there. So there are so many data sets. I will share the link with the coordinator as well. They will also share the link via mail or some WhatsApp group if it is there, or you can just note the AI indiaai.gov.in is the web link where you will find the all the government official data set. So I suppose if you are working on any project or any research problem, and if you are using the data set from this website, then obviously it will be have the more weightage than the normal or the customized data set which we have. So this is about the data set. Now, there are some other examples as well when we talk about the unsupervised learning methods and what are the problems in this. So these are the latest areas where you can work on. Some of the examples I have already shown, and now my focus is on the right side basically. That's why I am showing this slide in the forensic. Now we have seen there are various forgeries are there and the fake calls are there and the deep fake is there. So this is one part where we need to move on. Means our research must be on this part, that how we can recognize that this particular audio, video, or the visuals which we are seeing are authentic or fake. So means currently I don't have the much exposure on this. I am still working on this area. I have seen some research papers and some articles, white papers, where they have mentioned, clearly mentioned, that it is very, very tough to differentiate between what is the fake and what is the original, because the even we can say the accuracy in the fake one is much more. So the frequency of the original person language and the pitch is different, but the fake ones are making the system in such a manner that it is more original than original. So more authenticated than the original one. So we need to understand this thing and work on this, how we can recognize. Means on the fake news detection, you will see so many papers from the last 1 decade the work is on. But when we talk about the images, there are so many websites which are producing the images as well, means the images of the persons, images of the men, women, but these all are the hypothetical images. There are so many images which can be predicted by, and some of the data sets are also published based on this, where the person is not physically exist, but the software or the website is giving some predictive images on this. So how we can analyze and differentiate between this is a really a human one or a genuine image, or this is a AI generated image. So now the research is moving in this trend. So if I talk about the last slide, this one about the deep fake one. So what is the issue in this? Means can we say AI is now is means a bad thing for us? The deep learning, machine learning AI is bad for us, or means we need to improvise ourselves to use this AI and ML? Because there are so many statements given by the top technocrats, and it is clearly visible that even we are the common persons, but even they are seeking this. There is some sort of fear of the AI and deep learning models. So what can be the outcome of this? So this is again a thing to worry and need to work on this. This is one image I got, but I don't know the exact source because it is copied from the various websites. I got this from the various websites, but what is the original source of this? But yes, I am relating this thing, and that's why I have added in my slides. Yes, currently we can say yes, AI is good thing. The machine learning, deep learning model is there, and how we are evolving, we are seeing the problem statements. That is fine. But in the coming years, might be in after 20 years, after 50 years, there is a chance where we need to work on, or we are on the fast pace, not on the same just models. So if we are thinking on this area, research, we can give something to the society, then it is more beneficial for all of us. Means this is not only a problem in India. that we are discussing in our basic FDP. No, this is a global problem. Means you have seen the if the Elon Musk is there, the Sundar Pichai is there, and they are asking or giving the statements like this, means it is a global issue, and we need to focus on that how we are going to evolve with this all things. So yes, by 2040, in the image it is mentioned that we can thought of that yes, there is a risk of the jobs that now the things are the labor or the services are converted via artificial intelligence. But when we talk about, we have also seen various movies, and we can say like the in the robot movie and the means other Hollywood movies we have seen, yeah, the machines are taking over the humans. So this can be not the hypothetical things. We need to work on this and how the emotions and everything is coming to the machines. And even the scientists are working on, we are trying to see the results. But the results can be the positive as well as the negative. So we need to work on this area as well. So again, I am giving the research trend of next 10 years or 20 years that where we can focus on. So this is all about the data part. Now I am coming towards the ethics, because the last slide when we are talking about the fear of AI is about the ethics. If we are doing the research in a positive manner, we are focusing on the fairness, we are focusing on the transparency, we are focusing on yes, we have a data set and we can do the manipulations in this, but this is not a good thing. So you can just give a disclaimer with this that yes, this is a data set which we have taken from the AIMS and these much entries are deleted because of this and this reason. Yes, nobody is saying if you have tampered with the particular data set and you have removed some of the outliers because of your model is not performing, then they are not rejecting your research. But you are giving a valid reason that this can be the thing which can be worked on in future. These are the outliers which are now removed, and further we can work on this. Or the other researchers can work on this, and this is the original source of data. If you are giving some sort of things, that is fine. Similarly, if you are giving the modified data set, then what is accountability? Means, can you use? Yes, any questions so far? Okay. So if there is some sort of thing which we are saying, yes, this model works only on this data set, this won't perform better results on the another data set. So initially you can give this statement, but you have to give a disclaimer as well. You can just mention that the future scope is this and these are the other practices which you are working on. Similarly, if you are working on some sort of project which is related to the forensic or any other government body, then you should focus on the ethics, like the privacy, the security. There are some constraints about the particular organization or the agencies, so you can just focus on those as well. So if we researchers are focusing on the particular ethics, the society will also focus. If we are not focusing and we are thinking yes, it's up to the organization, it's up to the country, that in India the things are like this. No, so we start the things from us and then think about the society, think about the country. And similarly, this is a global issue now about the ethics, so we need to focus on this. There are various other parameters which we can focus on. So yes, you will see the basic things are there. So I am just skipping this slide because we need to focus on the trust, equality, fairness. If you are doing some research, then it can be a gender bias or these type of ethics are there. So I'm just focusing on the challenges and what are the acts and the laws driven by the India, and the global issues are there. So on the AI ethics. So these are some things which are under the challenges as well. And the still the researchers and the agencies are working on this, how you can preserve these things. Yes, these are some organization, the treaties, and we can say some of the proposals are there under the global level and the India level. They have created some uh, we can say the committees which are just giving their ideas on this, and they are giving some acts to ensure the AI is applied on the various fields and it is acceptable or not. So if we are working on something, then some project, we are working on some area, the domain, and we are giving some solution to the society, then it must follow the rules and regulations, because the solution which you are giving here in a particular local area or a particular district like Greater Noida. So it can be easily applicable to the worldwide as well. So you can focus on the AI ethics globally. These are three, four categories which we are seeing at the risk level. Like we are seeing the AI chatbots are there. So these are on the limited risk. The companies which are using the AI chatbots, they have focused on the particular act, and based on the act, they are on the limited risk. Suppose you are asking for a chatbot. Yes, I need the assistance on the particular policy, and they are suggesting you the policies. So these policies are on the limited risk. And to cover the particular suggestion, means if a chatbot is suggesting you to purchase a policy A, and then there is a particular resistance. If you are purchasing a policy A and you are saying, yes, this is suggested by the Policy Bazaar chatbot, so I am purchasing this, and if there is any risk, then the Policy Bazaar will pay me. No. So this is under the AI Act, that if there is anything which is suggested by the chatbot is not completely reliable. So these are the risk level, and I'm not going in depth for this because I need to cover a few more slides as well. And as the time is still 10 minutes more, I guess. So this is something which I just want to share for the awareness purpose. And I hope you are getting the headings and the subheadings, and further you can search and explore more if you are working on this area. So the sources are also used here. Now, this is something about the question answer part. First, I will start with the two, three questions from my side, and then you can ask the questions. So, very first thing is, as in my whole problem statements, I talk about the latest trends. So, if some research scholars are there who are joined as the participants, or the faculty members who are new in their PhD and just thinking to enroll the PhD, then you can also opt for the problem statements from the particular session, or you can just, I hope the session was help for you in your work based on the concept which I have shared, or some of the examples I took in this. And also those who are already PhD and the professors, and I request them that you can also focus on the funding schemes based on the some problem statements here. And there are so many other schemes which are still open by the DRDO, by the DST, ICMR. And as I said, that one scheme is already there, and the last date is the 31st August for to apply on this. So you can just focus on the research proposals. Why I'm saying, because already you are working on some research paper, you are working on some domain, and based on the domain and the model you are applying, you can seek a particular scheme. And under the scheme, again, you have to work on the same, because you have to publish a particular model, you have the results, the data set is something which is given by the particular organization, and you are just publishing the papers again on this. So this will be add on further in your profile, and you can just start the means in this new area or the new domain of the funded projects, and you can also help the society if you are developing some good thing on this. So just your add-on exercise will convert your research paper into the good proposal. So this is about the basics of my mm, session. Now I ask the speakers, do we have some more time, or directly we can take the questions?
So till 1 o'clock, we have time. If you want to share more thoughts, you may please.
Okay, so I have 5 to 10 minutes glimpse for the research scholars as well. So those who are new to the PhD, so there is a big question for all of them, that from where to start and how to start. So some of the research problems I have already shared, but now I am talking about the roadmap, that how you can execute your research work. So very first thing, as I said, the important part is which domain you are picking. Because some of the research scholars are asking that their guides are saying, the PhD supervisors are saying, yes, this is one area which you can took for your research, and yes, this is the latest one, or this is my research area. So you have to work on this, because now in the various universities there is a guidelines that your domain, the research topic must be mapped with the supervisor, and at least supervisor can have the 5 SCI papers on the same domain, and then you can opt for a particular supervisor. So yes, there are so many constraints, but still, if you are new to this and you want to start your work, then the very first thing is you have to opt for a particular topic. So as the topic, you can opt the topic as per the supervisor interest or your own interest, or suppose I have shared so many problem statements in my session slides. I will also share the slides. So you can pick the topic from this. Suppose you have picked a particular topic, say recommendation system. So I have taken one example. So this is a 5 minutes case study of a particular example. Like the recommendation system is there, which you have picked as a topic. Now, what is the first thing you need to do? Yes, very first thing is generally we do the recommendation. What is recommendation system? We are searching on this. We are just downloading the 50 or 100 papers from the Science Direct and the Springer, and we are seeing, yes, these are the paper, these are the methodology, and we are picking based on the supervisor's consent. We are taking, yes, this is a base paper, and we started working on a particular model. And based on the model, we are trying to see the code. Yes, somehow we can see the code is available on the GitHub, and some of the codes we are writing by our own in Python. And then we are using the data set, which is also there in our base paper. On the same data set, we are applying the models. We are seeing the intermediate results for the pre-processing, for the processing part, then how to optimize the result in better way. And then we are getting the results. And if there is a 5% and 6%, 7% difference in the accuracy, and our system is performing well, then yes, that's it. Two SCI papers and one Scopus or one conference, that is sufficient for the PhD. And all the norms are satisfied and the PhD is done. So this is our general approach which we are using or we are opting for. And yes, easily I am saying this, but I know, yes, 3 years and 4 years, how much pain you have to take for this simple approach as well. So this is the basic layout or basic workflow of a PhD work. But can we do, means if you are in the intermediary part, that is fine. But if you are just starting your research work in this domain or any domain, then you can focus on few more things. So I'm just talking about those things where you can focus on and you can improve your research experience, improve your research work. And in this manner, if you are focusing on, then the rejection of the paper will be less. So what are the basic things? You can just note them. So very first thing is, yes, go just select a particular topic. It's up to you. It can be any topic. And further, just study the basic layout about the particular, suppose the recommendation system is there. So very first thing I will understand, okay, the recommendation system work in the 5 steps. Step one is we are collecting the, means the input. Then the second part is we are just comparing the results. The third part is we are creating the function. This is just one example I am taking. Okay, so just to show what can be the small add-on things which you can do and how you can make your research in a better manner. And fourth step is say the rank and the recommend, and then we are evaluating the recommendation given by our proposed system. Yes, the recommendation is good or not, and evaluating the system with the help of accuracy, precision, and all things. So this is my first layout. So this is what we need to do in a very first step. Now, what is the next thing? The next thing is we need to focus on the approaches. Means the existing models. I am talking about the 100 papers or 50 papers which I am taking as a reference. I need to see the trend. The trend is we are using the machine learning or deep learning or this. Because when you are writing your survey paper, the first paper of the PhD, you have to just focus on what you are doing and how you are concluding your work. Basically, when you are saying I am focusing on the ABC approach, then everybody will ask that how you came to the conclusion that ABC approach is the best for this. So for this, you need to show the comparison of 100 papers or a comparison of the 50 papers based on the latest one, like in the from 2020 to 2024. These in these 4 5 years, these 100 papers are there, and most of the papers are working on the collaborative filtering, most of the papers are working on the content based filtering, and then you can say yes, that's why I am using this approach. So this is very common thing. Like I'm talking about this thing. This is one example I am showing here on the screen. Like if I talk about the 100 papers, out of those 100 papers on the latest one, the 30 papers are based on the content-based filtering and the classifier-based. 15% papers are based on the content-based, but they are using the neighbor-based algorithms. 37 papers are there which are working on the collaborative filtering where we are using the neighbor base. Similarly, the 29 papers are there with them working on some model and talking about the collaborative filtering. So when we have this type of survey, and then I am concluding, yes, the collaborative filtering is there, which is used. And if in the recent trend, I am saying, I am making one more table where I am saying in the last 2 years, most of the papers are focused on the hybrid filtering, where they are using both the content based as well as the collaborative filtering. So this is something which we are using. So if your base paper or your the survey paper is there where you are focusing on these type of things, then it will accept. So these are something which we need to focus on. So first analyze what type of, and then it is in the depth that what is the difference. I am not going in depth about this. So just focus on and then try to explore more on this. Like for the collaborative filtering, what parameters you need to use? You need to use the user item matrix, or if you are using the content based filtering, you need to use some the means this text document and the inverse document filtering. These type of things are used here. So first thing is to analyze what is in the trend, what you are expecting. Then you focus on the pre-processing, processing, and all type of things. Don't just focus on, yes, you are seeing recommendation system and the code is available, means this model is in use. No, on the comparison of 2 or 3 papers, the work with won't means acceptable. You need to show the top researchers on this. Next important thing. Now, how you are finding out the 100 papers or 50 papers on this? So the another important thing is if you are working on a specific domain, so focus on the top researchers in your domain. Like the example I am taking here is the recommender system. So the recommender system I am searching on, you can have the Science Direct, you have a Google Scholar, you have the Scopus.com, and based on this, you are just I am just again skipping this. Just skipping this here. This is the domain wise. The recommender system is mainly about the movies, so I am picking the movies data set. Again, this is something which I am talking about. Just see the trend. What is the trend? What is the latest trend? So that you can easily compare your work with the existing works. Similarly, focus on the data sets. What type of data sets are available? And based on this, you can just see the gaps are also there in the particular research paper. Yes, the latest as I said, the outliers is there, or they are using the content based filtering, so why not they are using the collaborative filtering? In the collaborative filtering, what are the other issues? Is there any the collaboration of the same age group or not? Suppose the collaboration of the users are there on behalf of the one is of the 30-year-old and another one is a 58 years old. If the data set is available in this manner, then you have to again categorize based on the age. Yes, let me come to the main part. Yes, how you can improve the quality of your research. So to work on the particular area, first, how you are fetching the good papers or the researchers. So you can just focus on, suppose there is recommender system. So on the recommender system, I am sharing the list of these 7. Means this is one example. You can just focus on your own research domain and search for the means persons of your domain. Here, all the persons are from the renowned organizations and they are working on the recommender system and the citations are good. In most of the organizations, you will see the citations are more than 1 lakh. So these are few things. So very first thing is you can opt for the papers or the authors from the domain and the good organizations, and you will also see the papers, research papers of these are well cited. So if your research paper is in such manner, then it will be appreciated. Another important thing as the data set. I already discussed about that the data set must be the authentic data set. Then the models and implemented theory. Just don't rely on the GitHub code. Try to focus on this and opt for the better ratio between the training and testing data. Then the parameters, it depends on you. and your outcome, that your parameter will be a single parameter as the outcome, or you are focusing on a big domain or the multi-domain part where the outcome is on behalf of the various parameters, then how the resources and what else you can do in the improvement and the research. So basically, the very first thing is the search of a particular researcher or the domain expert in your domain, and then the good research papers. If you will follow the good research papers, then for sure you will give something good to the society in the form of research paper. If your references are good, your milestones or base papers are good, then obviously you will do something good. If you are just focusing on the other conference papers, basic papers, or some other non-SCI journals, so this is one advice from my side to all the research scholars. So this is all from my side. And thank you, ma'am, for giving me the extra 10 minutes, because I just want to share this for all the research scholars. Because if you are just attending a particular session, at least you will get something fruitful with you at the end of the session. So that's all from my side. Now, if you have any questions, then you can ask. I will be happy to answer. More or less, it is an interactive session. So means I am still consider myself as a new or the beginner in the field of AI. But whatever I have in my bag of wisdom, I am sharing in front of you with all of you. Thank you. Yes, am I audible?
हेलो
Hello. Yes, ma'am.
हाँ सॉरी सर नेटवर्क लॉस्ट हो गया था
Okay, so means at what slide should I repeat this, or I was audible to all?
दिस इज ओके नाउ
Okay.
if participants are having any questions then we may ask them
Yes, sure. Okay, that's
if
fine. Yep,
having any
my
questions,
email ID
they
is
can
there.
message also yes sir
Yeah, my email ID and contact number is there. If anybody wants to be in touch with me, then you can also contact via these information.
you just please message in the chat box sir if you have any if you want to drop your mail id
Participants can tag your questions. Thank you so much, sir. Somehow we lost our network. That's why we got disconnected.
Okay, no issue, ma'am. I have
Sure.
shared my mail ID and the contact number in the chat box.
Yes,
And
sir.
if anybody wants to contact or they are having any query, then they can ask.
Sir, definitely, sir. Sir, we will share on the group also. Thank you so much, sir, for your insightful session and valuable contribution. Your expertise has truly enhanced our understanding and knowledge, sir. Thank you so much, sir.
Okay, thank you, ma'am.
Thank you all. We will start the next session at 2 p.m. Thank you, sir.